Whenever in science we do any experiments, we obviously will measure something, but we also need to be aware that whatever we measure, there will be inherently some uncertainty in our measurements. So what am I talking about? Let's say, for example, I want to know my weight. So I want to measure my weight. So I get the bathroom scales out, step on it, and record the weight in kilograms or stones or whatever you, pounds, whatever you want. But obviously, this weight, this measurement, and this is also called here, this is the measurand. This is what I want to measure. There is some uncertainty in it, and I indicate that usually with a plus or minus a given uncertainty. And uncertainty very often is abbreviated with a lowercase u, which stands for uncertainty. And this uncertainty can come from different sources. For example, it can come from the accuracy of the bathroom scales. So the accuracy, how good are actually these scales, and that very much depends on the resolution. How exactly can I measure things? In the case of a bathroom scales, it would be, can I measure it to kilogram resolution or 100 grams or grams or something like that? Anything that is below this resolution, well, I really don't know, so there would be an uncertainty in it. So this comes from the equipment. It could also come from other sources. So for example, it could come that the equipment might be sensitive to temperature or something like that. The uncertainty can also come from another source. For example, if I weigh myself over several days, I will find that my weight is not always exactly the same. It will fluctuate. And this uncertainty comes then from variation in the measurements. Variation in measurements. So one day I weigh, say, 82 kilograms. The next day I weigh 83 kilograms. If I weigh myself in the morning, I'm usually lighter than in the evening. So there is a natural variation in it. And it doesn't mean that anything is wrong or that there is an error. It is just simply an uncertainty. And what I can do is I just simply say, okay, I can measure a mean, an average, plus minus a standard uncertainty. Standard uncertainty. And it used to be called standard error, but I don't like this expression error, because error indicates that we've done something wrong. And we haven't done anything wrong. It is just simply something that we can't totally define. There will always be some uncertainty. Now, when we write this as measurand plus minus the uncertainty, this uncertainty can come in different forms, and very often it is not really specified what form are we talking about. So let's quickly talk about these different forms that this uncertainty is derived from. In the simplest case, it comes from what is called the standard uncertainty. Standard uncertainty. Uncertainty. And this is usually abbreviated with a lowercase u. This just simply means a standard variation in our measurements. Now, if we combine measurements with uncertainty, then we might get standard uncertainties, but they are combined. So I take for example, I measure my weight plus the weight of the dog if I hold the dog. Both are measurements with uncertainties. So my weight has an uncertainty, the weight of the dog has an uncertainty, and we basically combine our weights and we also combine the uncertainties. And I will show you how we can combine uncertainties. So in this case, it would be a combined uncertainty, combined standard uncertainties, standard uncertainties. It is still standard uncertainties. We haven't done any manipulation with it. We could have an extended uncertainty. Extended uncertainty. This is usually abbreviated with capital U. An extended uncertainty is just simply we take our standard uncertainty and multiply it by a factor k. This factor k is also called the coverage factor. And we will see what this does later on when we talk about different ranges and different coverage factors for uncertainties. And the last one would be an extended combined uncertainty. Where we have our combined uncertainty times the coverage factor k. And really the difference between extended and standard is just simply the presence of this coverage factor k. In the next few videos I will explain how we can actually determine these U's, either the standard or extended combined uncertainty, because that is really important if we want to accurately and properly report any kind of measurements that we make. We can report uncertainties in two different ways. We can report them as absolute uncertainties, where our measurand and the uncertainty both carry the same units. So for example, our measurand, if it is 50 gram plus minus 1 gram, which would be the uncertainty here, and we see that both the measurand and the uncertainty carry the same unit. We can write it either this way, where we have the unit both at the measurand and the uncertainty, or you can also write it like that, 50 plus minus 1 gram. Basically you've got the gram factored out. Both versions are equally right. So this is one way, the absolute uncertainty, where we've got it expressed in the same measuring units. In contrast to that, we can write it as the relative uncertainty, where we would give it the uncertainty as a percentage of the measurand. So we would write 50 gram plus minus 2%. And here we see that the uncertainty does not have the same unit as the measurand. There's no gram here. It is just relative to the measurand. How do we get that? Well, we just simply take our absolute uncertainty, so 1 gram, and divide it by the measurand, 50 grams, and multiply it by 100. So this gives us 2% for the relative uncertainty. And in this case, it's absolutely clear. You can't write this in any other form. You have to write it as 50 gram plus minus 2%. And you will see that quite frequently. We will need to work with both absolute uncertainty and relative uncertainty because both have different functions when we talk about combined standard uncertainties.